Great, thanks, Jeff. Again, before I get started, I just want to, if for some reason there's a problem with the voice or you can't hear, just please type into the chat window. We'll be monitoring that, and we'll be able to work on any technical problems to some degree. Okay. So once again, my name is Josh Robinson. I'm a data platform specialist with Microsoft. I work with Jeff on specifically focused on our state and local customers around the areas of SQL Server, BI, big data, all of those types of things. And I've spent portions of the last 6 months kind of digging into big data and what that means from a Microsoft perspective and what that means in general terms. I'd like to share some of that information with you today. Okay, so let's get started here. So just to give you a high-level agenda of the things that we'll be covering. I know Jeff mentioned them briefly, but just to show you from a high level, first we'll define big data. When we're talking about big data, what exactly are we talking about? Let's put some definitions out there and some examples of what it is that we mean when we say big data. The next thing, I'd like to make it as real as possible, and I'd like to talk about, it's great that we have these articles and in these systems now, and the data is available, but what are people actually doing with this in the real world? And more specifically, what do we see our state and local customers doing with big data? The next thing I'm going to talk a little bit about, I'm not going to go into a technical deep dive, but I want to lift the hood and just talk about some of the pieces that go into a big data solution. So when we talk about it, what exactly are the components and what are their roles within a big data environment? I want to talk specifically about Microsoft and big data. We're doing a lot in the big data area over the last couple of years, but we've announced in the last 6 months multiple different products focused on big data. So I want to talk about those very specifically and how you can begin to work with those as soon as this afternoon. I'm going to talk about SQL Server Parallel Data Warehouse, or PDW, which is our SQL Server appliance for handling large, what we call structured data solutions, and talk about why that's important and the kind of results that our customers see when they move their workloads onto PDW. And then I want to demonstrate this. I want to show you more than just slides. I want to actually show you how easy it is to connect our BI tools to Hadoop and to SQL Server and even to web data, and to bring those together in interesting ways and some of the visualizations that we can do with our big data solution and our BI tools. And then at the end, if there's anything left to discuss or any questions, we'll cover those. Okay, so before we get started, I'd like to just define big data. There are lots of definitions out there, so I wanted to pull one that was very clear and concise and kind of just covered it in one sentence or less. And so for that, I went to the Gartner Research definition. They're a well-respected research firm, and they define big data as high volume, high velocity, and or high variety information assets. So if you're talking to someone about big data, or you're reading an article about big data, more often than not, you will hear of the 3 V's of big data, and those would be, as in the Gartner definition, volume, velocity, and variety. And I want to just put a couple examples on the screen to show you when we talk about these, what are some examples of exactly what we're talking about. So they certainly cross over. Many of these would fit both the volume and the variety or velocity category, but just some examples. For census data, social and web data, text data, log files, spatial data would all fit into that volume category. Velocity would be sensor data, RFID or NFC, GPS, transactional data. And when we talk about variety, we're talking about data sources where you may be pulling from multiple places. It may change from day to day or week to week, the shape of the data, and that could be weather or event or traffic or crime, crime data. So those are examples of what we mean when we talk about the 3 V's of big data. Another quote that I wanted to pull in is from InfoWorld, which is a magazine that's been around for many years in the IT industry. And I think this is interesting. They say what we call big data today will one day simply be called data. Big data is not a fad, but it's rather a new phase in the evolution of data management. And I think this is key because big data is not something that's just a passing fad that's going to go away tomorrow. And I think the best analogy for that is service-oriented architecture. And if you think back to the early to mid 2000s, every other headline or every other article was about service-oriented architecture, SOA, S-O-A. It was all the rage. Web services were kind of coming into their own. And if you think about it today, there's almost no headlines about SOA or service-oriented architecture, unless that's the world that you're, the corner of the world that you're deeply embedded in. But for your average IT person, you don't hear about SOA like you did 10 years or 7 years ago. And the reason for that is because service-oriented architecture is just the way we do things today. It's part of almost every IT solution. So it's kind of hit the mainstream. I think that's where we're headed with big data over the coming years. The last quote is from a professor at Menlo College, and he says, big data is less about data size than having new data that's never been mined before and using the insights from that data. And I think the key here is big data in and of itself is, it's valuable, but it's just a bunch of data, right? It doesn't have any meaning. It doesn't add to your organization, in any tangible way, except that you have to store it somewhere. But when you gather insights from that data, that's when you really get the value. And I think the best way to show that is by, as you can see on the screen, I've got a journal article from a scientific research journal. It's called The Kinematics of Foraging Dives and Lunge Feeding in Fin Whales. And it's from the Journal of Experimental Biology. It's about 12 pages long. It's not that long. Looks like there's a lot of words. There's some diagrams and some charts, and there's even a couple pictures over there in the middle left-hand side. Is this something that the average person is going to read and consume and understand? I don't think so. But if you take the New York Times and you let them build an infographic out of this same, dry, perhaps dry research paper, then they can turn this into an interesting and useful graphic that even my 5-year-old can understand. And it talks about, hey, here's how a whale dives deep into the ocean, grabs a mouthful of plankton, and then swims back to the surface, right? So it's easily digestible, and I can gather some insights from this, even just in looking at it for 5 or 10 seconds. So that is the power of gathering the insights that are in the big data. That the value is not really just in having that data, it's in using that data in a proper way. You logged in. And the last thing I want to talk about when we define big data is that there are two aspects to big data. The first is the structured side. And if we look at all of the data in the world today, about 20% of the data is structured. And what this means is that's the data that you've traditionally worked with in a relational database system, that you work with every day in your data warehouse or your transactional system. And then there's this huge world of unstructured data. It's about 80% of all the data in the world today. And in this picture, it's represented by the portion of the iceberg that's under the water. And it's sometimes called dark data because to some degree, it's untapped data. We're just now beginning to make use of it. We just now have the systems that can work with this large volume of data. So when we talk about big data, there are these two aspects of it, structured and unstructured. And at Microsoft, we have solutions that work with both structured and unstructured data, and we bridge that gap because it may not look like there's a gap, but there is a gap between these two worlds, and it's important that you have the tools to help you bridge this gap so they're not disconnected. So why are we talking about big data? If you're a database administrator or a CIO or even a business person, why are we talking about big data? Isn't this the kind of thing that large internet companies, deal with every day, and they have all kinds of interesting problems, but why are we talking about big data? And the truth is, the world has changed. It's the cat's out of the bag, right? The big data systems are no longer just in the server rooms of the large internet companies. they're out there for you and I to work with on a daily basis. And as a result, relational databases that many of us are comfortable and familiar and probably know every nook and cranny of are no longer the only game in town. So we can't afford to just stick our head in the sand and say, hopefully this big data thing kind of passes so I can get back to, hey, tweaking and tuning my database. Yeah, you'll continue to do all of those types of things, but big data is here to stay. And I want to stress, this isn't a paradigm shift. This is not the case where, hey, we're replacing all the technology that's been around for the last 20, 30 years with a big data solution. That's absolutely not the case. Relational databases will continue to dominate in the transactional space. And in terms of small and medium data warehouses, and that may even reach into petabytes, you don't necessarily need a big data solution. So we'll continue to have data in both, the structured and the unstructured world. And so, as we go forward in time, many organizations will end up with data in both of these universes, and they'll need a way to bridge the gap. And again, we'll talk about this, but we're very interested, and we've already got a product release that will bridge that gap for you and make it much more easy to manage your structured and your unstructured data. So that's a little bit about the definition of big data. I'd like to spend a few minutes talking about big data in the real world. And on your screen, you should have a full-page picture of a pot of used cooking grease from like a fast food restaurant. And so what does that have to do with big data? Well, New York City had a problem. They had clogged sewers. And what they found is that 50% of their clogged sewers were as a result of restaurants dumping grease down the sewer when no one was looking, rather than paying a grease recycling firm to come and pump it out. So the Environmental Protection Agency in New York had to solve this problem. It was getting out of hand. And in the olden days, about 2 years ago, they would have had to send health inspectors to, they knew where the clogs were. They would have sent them to the block, one or two block radius around the clogs, and tried to catch a restaurant in the act of dumping grease into the sewer late at night, right? That's not an easy task. So fortunately, New York City has established a group of basically data detectives. They call them the Office of Policy and Strategic Planning, and it's about half a dozen people. And basically, these guys, their job is to find interesting data and solve existing problems in the city, such as the sewer clog problem. So what they found is that there was data from a agency in the city called the Business Integrity Commission. And it just so happened that the Business Integrity Commission certified whether or not a restaurant had a grease removal service. So what they did is they used their big data solution, and they took geospatial data of the sewer system, and they took this certification data for a grease removal service for each restaurant, and they overlaid the two data sets. And then they turned this over to the health inspectors. And basically, they were able to get a 95% success rate on tracking down the guilty parties on dumping grease. And they were able to solve the problem very quickly and easily without having to stake out the corner of, where the clogs were happening. So big data solved a very practical real world problem for them. In Boston, like a lot of other cities, they had problems with potholes. And so what they did is they crowdsourced the data. They wrote a smartphone app that people could run, and as they drove through the city, their phone would be on the dash, and it would bounce around, and they would use that data to detect where the potholes were. And then they combined that again with geospatial and other data in their big data solution, and they were able to find where the potholes were, where the ones that people hit the most, where the biggest ones were, and so they were able to solve their problem. They called the application Street Bump. So they worked with MIT to solve that problem. A couple more examples in New York City. So again, as they matured, I have a quote from the head of that group, John Feinblatt. He said, "Hey, we realize that there's enormous value in using all of our data together and proactively. We'd already done the retroactive act of looking back for accountability's sake. That's what a lot of us do today. So we tried to use the data prescriptively to figure out what might be coming next. And so along those lines, New York City has a lot of initiatives in place around using their big data. And for example, they're directing housing inspectors directly to law-breaking buildings where there's a catastrophic fire is most likely to occur. And they're using 20,000 different data points to find those buildings. In terms of making sure that elderly folks or people who are unable to leave their building are kept safe. They're working on a system to proactively determine in real time whose power and heat is out by combining their city data with real-time data from Con Edison, which is the energy provider up in New England. They continue to do interesting things, like they can look at any given parking meter and they can find out how many cars parked there on any given day and the number and the dollar amounts of tickets and the identities of the people that received them. So they're doing a lot of interesting things. And there's a great article in the New York Times that I've got a link at the end that talks about this group and all of the interesting things that they're doing. Another city that's doing interesting things with big data is Chicago, and specifically the Chicago Police Department. They have a predictive analytics group. It was founded in 2010. And basically the types of activities that they're engaged in are to find the areas that are at highest risk for near-term increases in violence, and they use that information to deploy police units. So it's not just a laboratory experiment, it's part of their police operation. And they do all kinds of interesting things. They look at the relationship between 911 calls and shooting statistics to predict where there's going to be a rise in shootings. And I wanted to show a real-world example of some Chicago crime data. And I'm going to use a tool that Microsoft has recently released, and it's called GeoFlow. And this is an Excel add-in. And this is actually using publicly available crime data from Chicago. And I'm just going to go up here. And the easiest way to show this, and it may not come across well on Link, so I'll give it a try. But the easiest way to show this is to click the play button. And you can see there's multiple panels over here on the left representing different scenes with data. If I click play tour, it's just going to go through each of these and I'll describe what we're seeing. So again, this is using publicly available Chicago crime data. And this is actually something I can send to you if you're interested in looking at this yourself. So what we're seeing is Chicago narcotics arrests in 2011, and they're color-coded by police beat. And what we're finding, we're kind of digging deeper, and we're seeing, okay, here's an area that has a lot of arrests at West Fillmore and South Homan Street. So it looks like there's a lot of arrests there. You can see the pie chart growing out of the ground. And then now we're looking at the individual types of arrests. We see they found suspect narcotics or cannabis more than 30 grams. It looks like there's a couple areas in the city, and I know there might be a slight delay as this updates on the webcast. But there's a couple areas in the city that look like there are more arrests than others. One of them at the top of the map is a public school. Okay, so there's a little bit of problem going on at the public school parking lot. In the bottom right, the Chicago Transit Authority train parking lot. Quite a few arrests happening over there. But the biggest number of arrests are happening at a police facility or a police vehicle parking facility. And I don't know for certain, but I'm guessing that the reason for this is that police are arresting people and then entering into the system. They're booking them when they bring them down to the police station. They're entering that as the place where they arrest them. So that's probably why the most narcotics arrests are occurring at the police facility. Now I'm going to show you this map, and I hope that that it comes across on Link. And again, I'm using some publicly available big data from Chicago, and I'm loading it into a tool called GeoFlow, which is publicly available. We'll send a link at the end of this, and it's an Excel add-in. And I'm using the geospatial data. And if I want to, I'm looking at Chicago, but if I want to see, are there arrests happening at O'Hare Airport? So I can just kind of scroll over here, and I'm looking at the airport now. And I can see, yeah, there actually are quite a few arrests happening over here at the terminal near the airport. And it's just interesting. I can just kind of do interesting things with this data and put it on a map and visualize it and animate it and look at it over time and find patterns in the data. And again, this all goes back to the data itself is not something that you can digest. Can you digest millions and billions of rows? No, a single person can't do that. But when you put it on a map, you can find interesting patterns and interesting exceptions, and you can drill into those and find insights in that data. And that's really the point of having big data. If it can't benefit you by giving you additional insights, then there may not be as much value in just holding on to that data. Okay, let's go back to our presentation. I'm assuming that my voice is coming across clearly. I know in the first session we had a little bit of audio dropout, but hopefully we've solved that problem. So please, again, type into the chat screen if there are any problems with audio or video. and Jeff is here with me, and he'll take care of that. Okay, so we've defined big data. We've looked at, why it's important, and kind of established that it's probably something that's going to be around for a while. So why don't we lift the hood and look at what a big data, an unstructured big data solution looks like. And for those that are technical in the audience, I'm not going to go that deep, but there are plenty of resources available to read up on this. And for those that aren't technical, don't worry, I'm not going to go that deep. But I do want to talk about kind of, hey, here's the motor, there's the battery, that's the tire. So we'll just kind of talk about at a high level what goes into a big data solution. So a term that you hear that's almost synonymous with big data is Hadoop. And Hadoop is essentially a database system. It's open source, and there's many components in it, much like the way that SQL Server is a name for a whole ecosystem of tools and utilities, one of which is the database engine. Hadoop is the same way. So if we look at the pieces that are in Hadoop, the foundational component of Hadoop is called HDFS, and that stands for the Hadoop Distributed File System. And so it's distributed. It's meant to be run across many nodes, although it can be run on just one if you'd like. And it's meant to be fault tolerant. It assumes that there are, it assumes that there are going to be hardware and software failures in your system. On top of HDFS, we have a framework that's called MapReduce. And MapReduce is basically, again, a framework for writing and executing distributed fault-tolerant jobs on top of HDFS. So it understands how to communicate with HDFS and how to bring the data in and how to break a job up into different smaller pieces. And we'll talk a little bit more about that. Hive. So Hive is, we're kind of getting warmer and warmer here. We're getting closer and closer to where an individual user will actually interact with Hadoop. So Hive, it sits on top of MapReduce, and it's a SQL-like, because it's not exactly SQL syntax, but it's very much like SQL, declarative query language. And people like you or I can write Hive QL or Hive queries against Hadoop and get data back. And I'll show you how to do that, how simple that is in a little while. The last piece that I want to mention is Sqoop. And Sqoop stands for SQL-to-Hadoop. And basically, Sqoop is a command line utility or a package for moving data between HDFS and relational database systems. The interesting thing about Sqoop is that it's Hadoop-centric. So it's really targeted at bringing data into Hadoop. It can export data out and into your relational system, but that's not really what it's designed for. So at Microsoft, we have a solution called Polybase, that I'll talk about a bit more, that is designed to pull data out of Hadoop and into your relational database system, which is typically where end users are going to interact with your data anyway. So we're really focused on that, and I'll talk more about it. There are other pieces in the Hadoop's infrastructure or ecosystem. I've just chosen to focus on these four. And then there are the pieces that sit outside of Hadoop, like your BI and reporting tools, your ETL tools, your relational database. Those can all communicate and interact with your Hadoop infrastructure. And if you want to know all the different pieces, there's all kinds of statistical engines and other query languages like Pig, for example, that are part of the Hadoop ecosystem, and you can easily find those by going out to the web. I'd like to just spend a couple minutes talking about each of these pieces and what they do. And the first one is the HDFS, or the Hadoop Distributed File System. So this is kind of the foundation of Hadoop. And this started at Google back in 2003. So Google, when they first set out to catalog the internet, they had to capture all kinds of data, clickstream data, web page data, the relationships between the web pages, and it needed to be stored and analyzed. And at the time, there wasn't a great system for doing that on such a massive scale. So they wrote a system, they called it the Google File System, or GFS, and their goals were that it be fault tolerant and that it scaled to multiple petabytes and thousands of nodes, and that it run on commodity hardware. The thing is, Google has never released that system. It's a proprietary system. They've kept it in-house. But what they did do is they published a white paper, and the white paper described the different, basically the different concepts that went into building this GFS, this Google file system. They published that in 2006. So the engineers at Yahoo read that white paper, and they said, you know what? There's some pretty good ideas here. So they decided to build their own version of GFS. And the lead engineer on that project was a man named Doug Cutting, who's very much alive and well and a big part of the industry today. And he led that initial HDFS project. And when it came time to name the project, after they'd been working on it for a while, he said, hey, let's just call it Hadoop. And Hadoop was actually the name of his son's little toy elephant. And if your screen has updated, you can actually see the elephant. Doug is holding the elephant here in the picture on the screen. And I read in an interview, he actually said that he's got the elephant in his sock drawer for safekeeping. And you know, honestly, this is the kind of thing you might see in a computer museum someday. I don't know. It's kind of cheesy, but it's really a big part of this you know, this environment, this open source big data community. So when Yahoo put together HDFS, their goals were very similar to the goals that of the original GFS system. They wanted it to scale to thousands of nodes, and it wasn't just large, you know, huge servers. It was commodity hardware that they wanted it to run on. They assumed that there would be failures, that hardware and software would just fail, and that the system needed to be able to handle that. And it was also designed to write once and read many. So it's very much a data warehouse or a reporting style environment versus a OLTP, you know, read write, you know, multiple times type environment that you might find in a transactional system. There are open source projects like Cassandra that's behind Facebook that will handle OLTP workloads, but that's not what Hadoop is designed for, or HDFS is designed for. And the last interesting thing about HDFS, if you were to actually browse it, it's truly just a file system. It's organized in directories and files, and you can go out there and copy things into it and delete things, and all the things that you would do on your C drive on your laptop. So it really is just a file system. The next layer is MapReduce. And I talked about MapReduce being a framework, and essentially it takes a MapReduce runs jobs on top of HDFS, and it's sort of that layer that is the last layer before you actually get to the underlying data. So I guess you could call it the engine of the database. And what MapReduce does is it takes a large problem or query and it divides it into multiple subproblems intelligently. It divides these into subproblems. And then it performs that same function that you're requesting on all of the subproblems across the different nodes where your data is kept. It then combines the output from all of these subproblems and returns the final answer back to the requesting user. So the first portion of this is the map, where it takes the problem and divides it and performs the work. And then as the answer comes back, that's the reduce portion. And the model is a wash, rinse, and repeat type model, where it may not get the answer that you're looking for in the first pass, but it'll do a second or third or fourth pass to get that data, to get that ultimate answer that you're looking for. There's a lot of great webcasts out there that you can watch that would go into detail on how MapReduce works. But yeah, it's actually pretty interesting if you get into it at a technical level. Let's talk about Hive for a second. So at Google, when they originally wrote this system, apparently they had no problem writing hundreds of lines of code to get a simple query back, because when you write a MapReduce query, that's what it takes. It takes hundreds of lines of code to do a very simple query with maybe a couple joins, a where clause, and a filter or two. So Facebook, when they started to use HDFS, they said, you know what? We want to make this a lot simpler. Let's put a SQL-like language on top of it. And so they produced a SQL-like language, and they called it Hive. And Hive essentially takes a SQL syntax and compiles it to MapReduce and uses MapReduce to execute the jobs and then return the results back up through Hive. So this is the entry point for a lot of end users. You can certainly write MapReduce jobs in .NET, but for most users, you'll connect to a Hadoop solution through Hive, and you would use Microsoft's HiveQL ODBC driver. And I'll demonstrate that for you in a couple minutes. But it truly makes it very easy to connect. And the last thing I'll just mention briefly is Sqoop. And as I said, it's SQL-to-Hadoop. And again, it's an ETL tool to move structured data in and out of Hadoop. It's great at bulk loading data. It is a command line utility, so it's a little bit of a learning curve there. But it's certainly a valid tool, and it's something that you'll probably use to move data out of your SQL relational system and into Hadoop. So there's a lot of value there. However, if you want to run T-SQL against your Hadoop and combine the results of a SQL query with a Hadoop query, Sqoop is not the answer. So we've developed this technology called Polybase that is a lot better at combining the results and running a federated query seamlessly across Hadoop and SQL Server. So we'll talk about that. So that was a peek under the hood of Hadoop, just some of the pieces and what role they play in this Hadoop, this big data solution. And a lot of times people ask, hey, that's great. So is Hadoop going to take over for the relational database? Where are we headed with this? And as I kind of alluded to earlier, that's not the right question. You don't want to throw away your current data warehouse, your current BI tools. And so at Microsoft, we're very focused on making Hadoop just an addition and something that will augment your existing solution and bring additional value. So the truth is, relational databases and Hadoop are designed to meet different needs. It's not a matter of bringing in Hadoop and all of a sudden all your data is going to be out on Hadoop. No, that's not how it works. You'll have different data out on Hadoop, and you may bring portions of it into your relational database, or you may query it through Polybase and return the results in combination with your SQL Server queries. So the truth is that both Hadoop and relational databases like SQL Server have a place going forward. One thing I'll point out, you see the elephant logo, and that all goes back to that toy elephant. So a lot of the companies around Hadoop will have elephants in their name or their logo. Like a big partner of Microsoft is Hortonworks. And there's a Dr. Seuss book called Horton Hears a Who, and Horton is an elephant in that book. So that's why you see the elephants in the names like Horton as part of the Hadoop world. Okay, so I've given an overview of Hadoop in broad terms, and as you probably know, Hadoop itself is actually an open source project, an open source database. It's part of the Apache organization. So Microsoft actually has a distribution of Hadoop called HDInsight. And so let's talk about what HDInsight is and how it ties back to Hadoop. And the truth is, HDInsight actually is Hadoop. It's just Hadoop running on Windows. Traditional Hadoop that's been around for a couple of years runs on Linux. And what we found when we polled our customers is that 91% of our customers wanted Hadoop on Windows. They said, hey, We have Windows Server expertise in-house, on our staff already. Well, we may know something about Linux, but we want to run Hadoop. We want to get into big data, but we want to do it on Windows. And so that was a big motivating factor in Microsoft kind of diving into this Hadoop world. We also wanted to bring Active Directory for security, System Center for monitoring and managing these Hadoop clusters, which can grow into thousands of nodes, right? So it's not the kind of thing you can just manage easily. So System Center is a great tool for Microsoft that allows you to manage and monitor those solutions. And we wanted our customers to be able to develop in .NET, because .NET is very much part of most organizations and most Microsoft customers, and we wanted to allow them to develop against a big data solution using .NET. Another factor is data connectivity. We wanted to make sure that SQL Server and SQL Server Parallel Data Warehouse could connect to Hadoop, that they would be able to easily kind of bridge that gap between this new exciting world of big data and the world of data that's been in existence and kind of runs all of the organizations today. So that was another big part of it. We also wanted to allow, as everyone moves to the cloud, we wanted to make sure that we had Hadoop up and running and that people could use their Azure storage and all the data that's in the Azure data market easily with Hadoop. And if you haven't looked at the Azure data market, it's actually pretty exciting. There's all kinds of free data out there. There's all kinds of data you can pay for, but it really is a great source of third-party data and government data as well. So if you haven't looked at the Azure data market, it's an interesting source for data, especially as you dig into Hadoop and start to play with it. It's very easy to load data from there. And our BI tools. So we wanted to make sure that as our BI tools continue to evolve, that they could easily connect to a Hadoop or a big data solution, and that it would be a first-class data source. So to that end, we wrote and distributed the Hive ODBC driver, and that's available today. And you can connect everything from Excel to Power Pivot to reporting services or any of our BI tools, or truthfully any client tool out there that has ODBC connectivity can connect to Hadoop through the Hive ODBC drivers from Microsoft. And it's not just limited to our HDInsight. This works against the open source Linux version of Hadoop as well. So if you have Microsoft BI tools and you have the Linux version of Hadoop up and running, you're all set. No problem at all. And another aspect was that in the last couple of years, Microsoft has been involved in the open source community. And that surprises a lot of people, but that is something that we're very interested in. And so we wanted to become part of this open source big data community. And so we collaborated with Hortonworks and basically worked with them to get Hadoop up and running on Windows, and then we contributed all of those changes back to the open source community. And they voted about 2 months ago to accept all of those code changes back into the source branch. And so now there's a branch for Linux and a branch for Windows. And we really are serious about this. In fact, the chair of the Hadoop working group for the Apache Foundation, his name is Chris Douglas, and he's a Microsoft employee. So it's not just lip service. We really are giving our changes back to the community. It's not just a matter of us taking that source code, making it run on Windows, and then releasing a proprietary product. It's very much an open source collaboration. So the Microsoft distribution of Hadoop, as I said, is called HDInsight. And if you wanted to run it today, there's actually 3 ways to do that. The first is via the HDInsight service, which runs in the Azure cloud, and it's very easy to get up and running. It doesn't require any hardware on your part. In fact, I'll show you after the demo. It's literally 2 clicks. If you have a MSDN subscription, and a lot of developers do, then you already have the access that you need to run Hadoop in the cloud. And you have a monthly allotment of, I guess, dollars or time that you can use to run Hadoop in the cloud. The other way is HDInsight server, and that would be on-premise. I'm actually running it on a VM, and I'll show you that as part of my demo. And truthfully, it's the same thing under the covers. I mean, it's just in the cloud or running on your server. And again, HDInsight server is very easy to get up and running, and I'll show you how quickly I was able to install and run it. It's probably the simplest install of software I've done in the past year. I don't think there's even a next button. There's just a finish button. And the last way, so let me just mention the first two, the service and the server, HDInsight service and server, are in preview mode right now. So you can download them, you can run them. Probably not something you're going to put into production unless you're part of a Microsoft TAP program, Technology Adoption Partner. But they're absolutely out there. You can absolutely run workload on them. But if you want to put something into production today on Hadoop, the easiest way to do that is to use Hortonworks HDP on Windows, and that stands for Hortonworks Data Platform, HDP. And Hortonworks, again, I mentioned, is our partner, and this Hortonworks HDP is what actually is sitting underneath HDInsight Service and HDInsight Server, and it has hit general availability. So it's out of beta, it's out of preview, it's ready to go, it's able to be put into production today. The difference is some of the friendly wrappers and things like that that you would get with HDInsight Service or Server are not necessarily in place. You're not going to have to download and compile source code or anything like that, but it's a little bit more nuts and bolts, a little bit more of a project versus a next finish or a click create in the cloud. Okay, so that's Hadoop, and I will come back to that in a second, and I will demonstrate that, and I'll show you, how simple it is to connect our BI tools, and how simple it is to get up and running with those Hadoop big data tools. But I do want to spend just a couple minutes talking about SQL Server PDW, or Parallel Data Warehouse. Now, I don't know if this is something that a lot of people have heard of, but it's been out for about 3 years. We released it in 2010. And basically, this is our Microsoft SQL Server scale-out solution. A lot of people ask, how do I grow my SQL Server? And this is our scale-out solution. So I'll talk a bit about that in a second. We just released version 2 back in March, and version 2 is based on SQL Server 2012. And it continues to become cheaper, faster, and more powerful over time. And this is the kind of thing that we update as we go. So there's always new hardware coming out. There's always updates to the software. So it's not just stuck at a point in time. So what is PDW? So first, PDW is a shared nothing parallel database system. And it's built on an MPP architecture, or massively parallel processing architecture. And when I say shared nothing, what I really mean is that each node is independent and has its own memory and disk, and therefore there's no single point of contention. They're not all fighting over the same SAN or the same network connection. Each node is independent, much in the same way that we saw with Hadoop. And the MPP, the massively parallel processing architecture, really just means it's a scale-out solution. Traditional SQL Server Enterprise is a scale-up solution, and it's worth noting that traditional SQL Server can still scale up to massive size. For example, one of the largest stock exchanges in the world is NASDAQ, and they handle over 1 billion transactions a day, and they require 50 milliseconds of latency per transaction, and that runs on SQL Server Enterprise. So you can scale up traditional SQL Server to massive scale. But if you want to scale out a large data warehouse solution, and again, we're talking about structured data here, that 20% structured data, Parallel Data Warehouse is the solution that you would look to for that. So it's delivered as an appliance, and it's not a matter of ordering parts from Dell or HP and then building a rack and kind of setting it all up. It's rolled into your data center and it's plugged in and it's ready to go. And it truly is, I guess the closest thing from a consumer perspective would be bringing a refrigerator into your house. You just plug it in and you start putting food in it. And so in this case, it's data. So as far as your client tools or your developers are concerned, this is SQL Server. When it comes time to support it, we have a dedicated staff of engineers, and they're always connected and monitoring your parallel data warehouse. They handle all the updates. So there's not a lot of care in feeding. You just fill it with data, and it spits it back out. So I don't want to, this is a big data solution, but it has a low barrier for entry. So we say any data, any size, and it can be structured or unstructured. And although the system itself doesn't hold unstructured data, this is where our poly-based technology is actually delivered. So we can seamlessly connect to Hadoop for big data integration, and I'll talk about that briefly on the next slide or two. And you can start small. You can start with 15 or 20 terabytes, quarter rack, and you can scale to up to 5 racks and 5 to 7 petabytes of information. So it's a solution that you can start very small and grow over time. And there is a low cost of entry. It's the lowest price per terabyte of all database appliances in the market today. So we're really proud of that. Microsoft is always great about competing on price, but while still maintaining the performance, and that doesn't change when we talk about our parallel data warehouse appliance. And if you were to want to look at parallel data warehouse, the easiest way is to engage with Jeff or myself, and we'll bring in a PDW specialist, and they can talk to your group, your IT group, or your CIO, and talk about what it means. We can schedule an architecture session or a deep dive or whiteboard session with a partner. We have many parallel data warehouse partners that we can work with. We can actually bring you to the Microsoft Technology Center, the MTC. There's multiple MTCs across the country, and there's one in each territory, at least one that has a PDW. And what we'll do with a POC is we'll bring in your data, take a backup of some set of your data, and bring it in and restore it on a PDW, and let you actually pound away and see what kind of results you get. And you can see on the screen, I just got some customer feedback on some POCs where we did a lift and shift and basically took a backup and restored the customer data onto the PDW, and just the results that they got were pretty astonishing. I mean, the first one, the query went from 5 minutes to 1 second, and they just couldn't believe it. The second one on here, they were looking at 6 months of data, and the query times went from 90 minutes to 49 seconds. They really didn't think that they could get that kind of performance out of a SQL Server solution, they said. They'd been running on SQL 2008. In the UK, a public transit system, they were able to load their data 10 times faster, and their data transforms went from 4 hours to 136 seconds. And then they put 200 users against 7 years of data, and the queries went from 2 hours to 12 minutes. So it's not a solution that's only for large data sets. It's for high levels of concurrency. If you have public-facing data sets that you have a lot of concurrent users, then this is probably an answer that you can look at. And again, it really is cost-effective. And please reach out to Jeff or myself if you want to look at what that would be. The last thing I'll talk about with PDW before I get into the demo is bridging that gap between the relational world and the big data, the unstructured Hadoop world. And when we want to bridge that gap, there's 2 ways to solve that problem. And I have to give credit on this slide to Dr. David DeWitt, who's our lead, I guess, big data researcher and kind of leads that practice at the Jim Gray Research Lab. And basically, the open source way is Sqoop, and there's a lot of value there. Again, it's command line, but if you want to get data out of your relational database and into Hadoop, then you run Sqoop and you bring data in, and you can actually export data as well, but it doesn't really bridge the gap. It allows you to move data back and forth, but you can't query or federate that data. So what Dr. DeWitt and his team have been working on for several years is a product called Polybase, which is part of PDW. And Polybase lets users or BI tools run T-SQL queries against SQL Server PDW, and they can federate the results of their SQL query with HDFS seamlessly behind the scenes. So they would have no idea that they're even connecting to a Hadoop server. And as you can see, we kind of cut out the middleman. On the left-hand side, you're still dealing with MapReduce and those layers between you and the data. And when we talk about Polybase, we're going straight to HDFS. We're going straight to the underlying data. We're not running an interpreted query. So it's run in parallel against all the nodes. The results are returned to SQL, and SQL then unions and returns the structured and the unstructured data together in a single result set. So it really is powerful stuff. I know I'm just kind of glossing it over, but if you're looking at a big data solution and you want to allow your users to easily access it, this is absolutely one of the easiest and simplest ways. They've already talked about, again, version 1 is released. It's part of PDW. It's in production. But they've already talked about what they're going to put in version 2 and version 3. So this is very much an ongoing project. And they've also, Dr. DeWitt has also publicly announced that it's very likely that this technology will find its way into SQL Server Enterprise at some point in the future. So today, the way to get to this is through PDW, and in the future, who knows when, it may find its way into SQL Enterprise. Okay, so I'd like to just take a few minutes to show you basically the Microsoft BI tools against Hadoop and how we can easily bring data, structured and unstructured data together, and what it looks like to query Hadoop. And then after this, the last thing that I'll talk about is, hey, if you want to get started this afternoon, how quickly can you get up and running, and where do you go, and what does it look like to get these tools installed? So I'm just going to bring up my virtual machine. It should be on the screen shortly. And so you can see I'm running Windows Server 2012. I'm running in a virtual machine. And I've installed HDInsight Server, which is our on-premise installation. And again, it's so easy, I don't think there's even a next button. There's just a finish. So when you install HDInsight Server, which is Hadoop, you have 3 web links right here, and you have a command line, and that's it. And it's up and running, and it's ready to go. So these web links are basically allow you to check MapReduce job status, the status of your name node, and there's a dashboard. So I'm going to click on the dashboard, and you can see it's coming up on a web page. And I've got one HDInsight cluster. It's my local, so I'll click on it. And then from here, I have a set of tiles that kind of serve as a landing page. And we really are serious about making this easy to get into. When I first kind of loaded this up about 6 months ago, I really didn't know what I was going to get. I really didn't know where to start. And thank goodness it's all kind of here for you. You have a Getting Started tab, which takes you to all kinds of interesting links. You've got the documentation, which is not the normal dry kind of documentation you might expect. It's actually very easy to kind of parse through, and it has lots of great examples as part of the documentation. You've got downloads in the upper right, so I can download like the Hive ODBC drivers to connect my BI tools. And then in the bottom here, I've got remote desktop. And if I were running this in the cloud, I would just connect to this web page, and then I would click remote desktop, and I could literally remote desktop into my name node from my on-prem server. So remote desktop doesn't necessarily apply when I'm running the server on-prem here. And then at the bottom, I've got the ability to create a MapReduce job. If I want to sit here and write hundreds of lines of code, I could do that, or I could certainly program that in .NET. I've got the ability to create a Hive job, which is very much like writing a SQL statement, as I'll show you. And then from here, I can even just click this, and I can deploy sample data. So we don't just kind of leave you with a bare bones installation. We actually also load some sample data so you can get up and running right away. And as I said, Sqoop is very much part of what we're doing here. So Polybase doesn't replace Sqoop. It's sort of a it augments Sqoop and gives you an easier way to connect from the relational database. So in a second, I'm going to run a Hive job, which again isn't probably like saying I'm going to run a SQL query. But first, let me just show you the command line, the Hadoop command line. So I click it, and I'm going to zoom in here. So forgive me if this jumps around a little bit. Trying to get it centered. So you can see I've got my Hadoop command line. And from here, if I wanted to run a Hive query, I would drop into the Hive command line interpreter. So just type Hive and hit return. And now you can see that my cursor is next to the Hive command line interpreter. So if I want to run some Hive queries, let's see, the simplest one is I'll do a show tables, and I'll end it with a semicolon. And it's not all that friendly, but it tells me, okay, I ran the command. And then the next line, it says census and census_demo. Those are the two tables that I have in Hadoop right now. And it took about 0.3 seconds to run the query. So, okay, some useful information. Still it's still just a command line, so it's not all that glamorous. If I want to look at one of these tables, I can describe formatted. Let's look at the census table. I spelled it wrong. Describe formatted census. And okay, so it returned some information about my table. Let's see, hang on. Okay, so I can see I've got the OK. And then here I've got the column name, the data type, and a comment. And I can see, okay, I've got a state identifier, a county identifier, population. These are ints, big int, a string. So I can learn information about my table from the command line. But again, this is not the easiest way to work with a query or the output of a query. So I'm going to drop out of this. And I'm going to go back to zoom back out and go back to my dashboard. And I'm going to go to the Hive job. And again, this is a little bit friendlier way. So we've included basically in the browser a JavaScript Hive environment that you can write queries. Yeah. Yeah. Okay. So sorry about that. So from here I can run Hive queries, and it's a little bit easier to see the output. And you can see it has some friendly things. And keep in mind this is preview code, and I'm running a small resolution, so things are a little bit crammed together. But I can click on a particular table here, and you can see the metadata is displayed. So just a little bit of hand-holding here. And just by clicking on census, it populated the right-hand window over here with select star from default.census. Default is basically the data space that I'm in. Limit 10, and limit 10 is the equivalent of doing a top 10 in T-SQL. So I'll click Run Query, and you can see you may have multiple jobs running. So from here, I can see all the jobs that are running. Everything I've already run is completed, but I can see the spinning wheel down here. This one's still running, and when it's finished, I will click Output. Let's see, still running. I'll go back to Queries. Should be done in just a second, and there it is. And so now I can see the output of this query. And again, it's a little bit friendlier. It's better than a command line. At least I separate the data and the log output. I can separately. I can look at the log and say, there's the OK. There's the time that it took. Kind of familiar information that you saw in the command line, but it separated my results. So okay, a little bit simpler, a little bit easier. I'll do one more query. Let me go to my editor. If I wanted to create a table in Hive, I'm going to copy and paste this so you don't have to watch while I type it. But this is how I would create a table in Hive. So it's similar to SQL syntax. Just call this census Josh. And you can see I define my columns, state, identifier, county, population, population over 69, et cetera, et cetera. I've got a comment in there to describe the table. And talk a little bit about the source data. The source data is delimited by a tab, and it's stored as a text file at the following location. So what I'm doing here is I'm taking data that I've loaded into HDFS already, that's stored at the user/demo/census directory, and I'm putting an external table on top of it that a BI tool or even SQL Management Studio through a linked server could connect and understand columns and return rows of data. So that's what I'm going to do. I'm just going to go ahead and run my query, and it's just going to kind of grind away for a second, and eventually I will have a new table. And I'm not going to see too much in the output. It's just going to, at best, it will return like an OK. Your table was created. So that's great. But again, it's still not the easiest thing in the world, right? So there's got to be a better way, and there is. So let me just show you. Minimize this. And if I want to connect to this, and I want to do some reporting and some BI on top of this, and maybe I want to connect it and merge the data with some other data sources, there's a very easy way to do that. And I'm just going to open Excel. And we have a BI tool. You may have heard of it. If not, I'll describe it. It's called Power Pivot. And Power Pivot is, at its heart, it's an Excel add-in. And it combines basically three technologies. The first is an in-memory database, so that you can query data from an external source. And because it has an in-memory database, you can hold millions of records locally. It has a data modeling environment so that you can easily, without having to write queries necessarily, you can easily connect to external data sources and build relationships and build calculations and formulas and all those, and hierarchies and all those types of things. And then there's a visualization component. And within Excel, we use the Excel visualizations, which have really come a long way from the earth tones that you might be familiar with from 10 years ago. You can get some great visualizations in Excel 2010 or 2013. And then we have other tools that sit on top of your Power Pivot data model, and tools like GeoFlow that I showed earlier. Tools like Power View, which allow end users to drag and drop and create visualizations kind of without even worrying too much about the data or where it came from. Obviously, it would benefit them to know what they're building, but they don't have to worry about the nuts and bolts. So this is kind of the starting point for a lot of that, this Power Pivot environment. So I'm going to go ahead and, there we go. I'm going to go ahead and click on the Power Pivot tab, and I'm going to click on Manage. And so Manage just opens up my Power Pivot data modeling workspace. And from here, I'm going to connect to my data sources. So what I'm going to do is pull in weather data from SQL Server. I'm going to pull in census data from Hadoop. And I'm going to pull in state abbreviation data from the U.S. Postal Service website. And I'm going to put these three data sources together, and we'll look at flash floods as they occurred during Hurricane Sandy. And the population that was impacted by these flash floods. I'm going to do a shortened version of this demo. The full demo is, the script is available on the web, and I've got a link at the end of this presentation. So it only takes about an hour to do the full end-to-end demo. I'm just going to spend about the next 5 or 10 minutes showing you here. So the first thing I'm going to do is pull in data from SQL Server, and I'm going to connect to another VM that I have running that has SQL 2012 running on it. Just going to click Test Connection. Make sure that it connects. Should be running. It's another VM right here on my machine. Okay, there we go. Just had to wake it up. And I'm going to connect to NOAA, which is the National Oceanographic and Atmospheric Administration. And I'm going to pull in my weather data from here. So I'll click Next. and it's talking to SQL Server. Again, this is all running on VMs on a laptop, so it takes a little bit longer than it would from a powerful server. I certainly could write a query. I've already written a view that has the data, the flash flood data that I want. So I'm just going to select from a list of tables and views. So I'll click Next. And it queries my server. And here's a list of tables. And at the bottom is the view that I want. It's flash flood. I'll click Preview and Filter to make sure that this is the data that I want. Looks correct. Yep, that's what I wanted. So I'll click OK. And I'll click Finish. And so what happens next is I'm importing the data from SQL Server, and I'm going to hold it in my local in-memory database. And on my local desktop, I can hold millions of rows with no problem. And if I push this to the server, I can easily hold billions of rows with no problem. So desktop is kind of the self-serve, just for me, and maybe I can share with others through SharePoint. And then if I want to share with the whole organization or with the general public, I would push it to the server, and I could have a much more, robust, basically set of hardware behind it and handle billions of rows and some additional features. So I'm going to click Close, and you can see there's my actual data. So the next thing I'm going to do is bring in data. I'm going to connect to Hadoop, and as you know, Hadoop is running actually on this very same VM. And you can see just as I scroll down, we connect to obviously all of the Microsoft database servers. We'll gladly connect to Oracle or Teradata or DB2, bring data in from there. And then ODBC is how I'm going to connect to Hive. You remember I've been talking about the Hive ODBC connector. But there are others. We can even pull in from obviously a text file, CSV, or web data. Even a reporting services report can be used as a data source. If you don't have direct access to a data source, sometimes you do have a report that would get the data you want. So I'm going to connect to ODBC. I'm going to hit Next, and it's going to be HDInsight. And I'm going to click Build Connection. So again, this is ODBC, so I'm going to I've already built the Hive ODBC connector. I'm going to connect to the default data space, and I'll just click Test. I always like to get that succeeded back. Click OK. Click Test once again just for good luck. And there we go. I've connected to Hadoop. It's that simple. I'll click Next. I could write a Hive query here, but you've already seen that. I just want to pull in the entire census table. So I'll click Next. And you can see actually there's Census Josh, the table that we created just a few minutes ago. You can actually preview that. This isn't part of my demo script, but it worked. And so you can see there's the data that I created in that Census Josh table. It should be the exact same data as census. I'm going to use the census table. Click Preview and Filter, and I can see, yep, that's the data I wanted. So I'm going to click OK and click Finish. And now my data is coming in from Hadoop. So I've got data from SQL Server, flash flood data. I've got census data that I just brought in from Hadoop. And the last data that I'm going to pull in is from the National or Postal Service web page. So I'm actually connecting to the U.S. Postal Service over the web and pulling up their web page. And this is where they have their official abbreviations. So I'm going to just highlight this in HTML. And I'm bringing this data in just basically for the purposes of the demo to show you how we can connect to multiple data sources. But this is where I have the official U.S. Postal Service abbreviations. So if I want to use these as part of my data set, I've got them available. So I'm going to click Copy. And I'm just going to drop these into Excel. Put them in a new tab. Call it Short State. And I'm just going to paste. And it's actually, it recognizes that I'm pulling from a web source, so it's actually querying the web directly. It's not just doing a blind copy paste. And so that's why it takes a little bit longer. And I'm pulling that data in. It should appear any second. And it's still querying the web, querying the U.S. Postal Service website. And there we go. And the data's in. So I'm just going to do a couple quick things. I'll format as a table. to make it a little bit easier to read. And I'm going to name the table, instead of calling it table 1, I'll call it short state. And I'll rename the columns just to state, and since we've called everything else short state, let's call this short state as well. And I'm done. And so now if I want to merge my Hadoop data and I want to merge my SQL Server data with this US Postal Service data, it's as simple as clicking on the Power Pivot tab, Add to Data Model, and there it is. And it's now a first-class citizen in the same way that the Hadoop data is in here, or the SQL Server data is in here. Okay, so I'm going to click on Diagram View. And if you stop and think about it, if you were to do this, if you were to combine, SQL Server data, with Hadoop or with some other data source, and then with the web, let's say 5 years ago, it wouldn't have been a matter of a couple clicks and maybe 2 or 3 minutes, although I've kind of dragged it out by talking. But it would have been a whole afternoon of kind of working with Access and Excel and some queries and kind of trying to figure out how to get all the data to match and bring it into a single place where you can work with it. So it's really a pretty powerful model to be able to connect all these data sources, bring the data in, and then build relationships. So I've got the data, and it's not just coincidence that there's relationships. The key that I'm going to connect actually has the state ID and the county ID in both the census data and the flash flood data. So I'm able to just kind of join these two data sets. If there's not a relationship, I can't create a data set. I can't create a relationship where there's not, where one doesn't exist. So the data does have to have a relationship. And I'll connect the flash flood data with the short state data. And that's it. I've now created my relationships. I've now joined Hadoop data with SQL Server data and web-based data. The last thing that I'll do is just quickly create a hierarchy in my flash flood data, and I'll call it geography. And the reason I would do this, it's not required, but I want it to be very easy for my users to see that they can drill from state to county. If I didn't create the hierarchy, they could drag state out into the report, and they could drag county out into the report, and they could still drill and build that relationship dynamically. But by doing this, I kind of define that for them and define a drill path for them. And I won't do this for the sake of time, but I could certainly build all kinds of calculations and interesting things and hide different fields and rename. But for the sake of time, I'm just going to go straight to my report. So from up here, I'm going to click Pivot Table Report, and I'm going to drop it into a new workbook. Click OK. And from here, I'm really just using the Excel pivot table engine and the Excel visualization engine. And it just so happens that my data source on the back end is Power Pivot. And beyond that is, as you know, Hadoop, SQL Server, and Postal Service data. So from here, I'm going to pull in my hierarchy. I'll just click Geography, and it drops it down into my rows. And you can see, I've now got my counties underneath each state. And the next thing I'm going to do is just bring in some census data. Again, remember that this is coming from Hadoop. I'm going to bring in the total households, which is the best representation of population. And then I'll just do a little bit to format this. I'm going to right-click and put commas and drop out the decimal. Click OK. So there's my population data. We're only concerned about states that had flash floods during Hurricane Sandy, so I'm going to filter out or hide those states that didn't have flash flood damage in Hurricane Sandy. And the next thing, I'm going to bring in some more data from my weather service data. I'm going to bring in the flash floods hour by hour. So the first hour, the third hour, the sixth hour, and the 12th hour. And then from here, it's just a matter of using the tools that are available inside Excel. So I can highlight, a column, and then using the Excel visualizations, I can just put data bars or something like that to show, surprise, New York is the most populated state in the area, those types of things. And the next thing, if I want to drill into the individual counties, we know that New Jersey was hit pretty hard by Hurricane Sandy. So I've expanded the individual counties for New Jersey, and I could, apply the data bars to New Jersey, maybe put a different color on it to find the most populated counties, and then just simple things like put a heat map on top of it and find out, in this case, higher number of flash floods is bad, so I'll make red bad, and I can see that these were the most impacted counties. Okay, so that's great. That's just a quick visualization, but the point is that I was able to bring all this data together. The last thing I want to show you in terms of a demo is, again, with GeoFlow, I'm going to pull in a visualization that uses this same data. And there's actually an article about this that we can send you. Ted Malone from the Microsoft Federal team actually put this together as part of a demo or a seminar that he put on. But he used this same data set, actually a slightly expanded version of this data set. And he pulled in census data from the entire country. You can see the most populated regions of the country are the ones that you would expect, up in the Northeast corridor and Florida, and then California on the West Coast. So you can see population density, and then another view we focus on the Northeast. And then if you were to do the whole demo, which I didn't have time, the point of the demo is to show where the at-risk population is. Where are the elderly folks that may not be able to get themselves out of the way of the hurricane? So again, you can see this is where the most focused elderly population is. It's up in the Northeast, and then as you kind of scroll down, and it may not come across as clearly on link, but it scrolls very smoothly. You can see Florida has a lot of elderly population, and then as you kind of scroll out west, you can see Arizona. A lot of folks retire in Arizona or San Diego. So it's kind of what you would expect. But then we add another layer, and we add the flash flood data, and you can see that it looks like there's a certain area here that has the high risk of flash floods, and then also a concentrated population of elderly folks that we would want to get out of the way of this storm. So that's where we would maybe want to focus some of our emergency evacuation efforts. So again, just interesting things that I can do with this big data to gain hopefully some insights into it. And if you're interested, you can download GeoFlow today, and Jeff or I can send you this workbook, and you could just kind of play with it. The data is embedded in the workbook already. And again, it did come from that Hadoop solution as well. Okay, the last thing I want to show is back to the presentation. How easy it is to get started with HDInsight. And this is something, 6 months ago, I didn't know how simple this would be. I kind of thought I'd spend a week kind of digging into some bits and figure out how to work with this. But the truth is, it's incredibly simple. So if you want to do it in the cloud, as I said before, if you have an MSDN subscription, you've already got everything that you need as an individual to connect. You would just go to your management portal for the Azure cloud, and you can register if you've got an MSDN subscription if you haven't already from your MSDN page. And then from there, it's a simple matter of clicking New, and then choosing Quick Create, and you've got your HDInsight cluster. And I just want to show you in real time. I took those screenshots myself. It's just a matter of going to manage.windowsazure.com. Just load up a fresh copy of that page. So there's no smoke and mirrors. I didn't drop out some extra screens here. It's truly as simple as manage.windowsazure.com. I click the New button, click Data Services, HDInsight, and Quick Create, and I just decide how many nodes I want, 4, 8, 16, or 32. We're in preview right now, as you can see on the HDInsight, it says preview, so we're limiting to 32 unless you join a TAP program. But yeah, you can absolutely get in there, load some data, play around with it. If you wanted to do it on-prem, it's just as simple. Oops, minimize that. It's just as simple. So the demo I did today was on a virtual machine. So what I had to do to get that up and running was go to microsoft.com/bigdata. And then from there, I find the link for download HDInsight server. I think it's moved to the bottom of the page at this point. It's no longer right at the top. And it takes you to a button, a page where you click the Install Now button. And I click I accept. And as I said, there's no next. I just wait for, I don't know, 20 or 30 minutes, and it kind of downloads the libraries and the Hortonworks HDP platform and the different pieces that go into this. And you click finish, and you're done. And that's all there is to it. That's absolutely all there is to it. So I know that we've kind of hit the end of the time here. So I just wanted to highlight a couple of resources. I know I don't have the links kind of written out. Some of these are long, but we will provide this deck via a download link for anyone that wants it. Microsoft.com/bigdata is a great place to get started. If you really want to dig into the nuts and bolts of big data, and a couple of the slides that I used came from this, Dr. David DeWitt did an incredible presentation at the past 2011 conference. He did the keynote. It's about an hour and a half, and pretty much everything you would reasonably want to know about Hadoop and big data in an hour and a half. So that's absolutely worth, eating lunch at your desk and watching that if you're interested. New York City big data article that I referenced, Microsoft blog, Cindy Gross from the Microsoft CAT team, the customer advisory team, is very involved in big data. She's the one that wrote the script for the Sandy flash flood demo. So that's a great place to start on her MSDN blog. Once again, Cindy Gross. And then we have case studies. We already have people that are putting this into production. And we're using this, I'd love to talk more about it, but we're out of time. We're using this behind the scenes with Halo 4. So there's an interesting case study around that. I love to play games. I'm excited about the new Xbox, and that case study is absolutely interesting to read. But we're using it with law enforcement agencies. We're using it with healthcare, data services firm. We're using it with Yahoo. So we have case studies out there for both PDW and big data. And that was all I had today. Looks like we came in just under time. So thank you very much for attending. I sincerely appreciate it. And if you have any questions, please feel free to email either Jeff King or myself, and we'll be glad to engage with you further. Thanks.